Hey everyone, today we are starting chapter 4, which is focusing on exploring numerical data. Okay, so we learned a little bit about the difference between numerical and categorical data back in chapter 1. So we're first going to recall that, and then throughout this entire chapter we're going to talk about how to graph numerical data in various ways and how to interpret what these graphs are telling us and how do we describe these distributions. So first, let's recap. What's the difference between categorical and numerical data? First off, categorical data is when the outcomes fall into categories and are described with words. So outcomes fall into categories and are described with words. So some example of categorical variables could be eye color, blue, brown, green, hazel, favorite sport, political party, here at PCEP it could be homeschool, okay? It's where the outcomes are categorized. Your response is some sort of category. Now, numerical data is when outcomes take on numerical values with quantitative meaning. So it's when outcomes take on numerical values with quantitative meaning. So what do I mean by that? So one example could be height. If I asked for all of your height in inches, the higher the number you give me, the taller you are. Another one could be your test score from last chapter. The higher the number, the better you did. Your GPA. Okay? The numbers have meaning, have quantitative meaning. Quantitative meaning, the higher the number, has meaning for that. One thing that, where the response is numerical, but it's actually categorical, is, for example, zip code. So, for example, zip code describes a category of where you live, a geographical region on a map. Just because Canton zip code is higher than Plymouth zip code, it doesn't have any quantitative meaning. It's describing a category on the map. So zip code would actually be categorical. For example, jersey number. If you wear jersey number 12 and your friend wears jersey number 15, because their jersey number is higher, does that mean something? Does that mean they have a higher scoring average or they average more minutes played in the game? Nope, your jersey number is just kind of categorizing you for your gameplay and for the team, okay? It's not numerical, because if it were numerical, it'd have to have that quantitative meaning. So, in chapters 1 through 3, we focused on categorical data. Now we're going to shift to numerical data. There are 4 ways we're going to use to graph numerical data. One you've seen frequently so far, which is dot plots. Now, new to chapter 4 are the following 3. We're going to talk about today how to graph frequency histograms, relative frequency histograms, which are similar to frequency histograms with one additional step, and later on this chapter we're going to learn about box plots. Okay? But today we're going to focus on histograms. So what's a histogram? A histogram divides the values of a numerical variable into classes and uses bars to represent the frequency of each class. So, here are the steps to create a histogram. So I'm going to take you through these steps to create this histogram below for the data for the run totals for 30 baseball teams. But you're going to have to create a couple histograms in your homework, so it'd probably be a good idea to highlight this so you can reference it later when you're doing your homework. So first step, find your minimum and maximum. So go ahead and take a look at this data set and find the minimum and the maximum value. So your minimum should be 637. And your maximum is 901. Step 2, divide the data into 5 to 10 equally wide classes. Hint, start each category with a convenient number. So, for example, my minimum here is 637. 637 might not be the most convenient number to start at. So 630 might be better, maybe 620, 600, okay? Now, step 3, make a frequency table. Oh, sorry, hold on. Divide into 5 to 10 equally wide classes. Okay, so if I start at 630 and I go to like 910 by tens, that's going to give me way more than 5 to 10 equally wide classes. Even if I go by 20s, I'm still going to have way more than 10 classes. So maybe rather than starting at 630, we can start at 600 and go by 50s. So now I'm going to make a frequency table, okay? So it's a table with 2 columns. I'm going to have my class along the left side and the frequency. Frequency is the number of times something occurs in the right column. Now, I said my first class is going to be from 600 to 650, or in other words, 600 to less than 650. My next class, if I'm going by 50s, is going to be from 650 to less than 700. And the reason why I do it this way, and not just 600 to 650, 650 to 700, 700 to 750, because if I get the number 650, where do I put it? 650's in both of these. Or if I get the number 700, where do I put it? Okay, now here, if I get the number 650, oh, this goes from 600 to less than 650, so that's to like 649.99999. So that means 650's got to go in this class. If I were to get 700, it would have to go in the next class. Okay, and go ahead and do this until you cover all the way through your maximum. Okay? So now we got to go through and put them into their corresponding class, each data point. So I'm going to go through and count how many numbers are from 600 to less than 650. Give me 1, 2, 3, 4. So 4. Then from 650 to less than 700. And I kind of gently cross them out. This way at the end, hopefully all my data is crossed out, and anything that's not crossed out, I can go back and fill into its corresponding class. In the end also, you should make sure the numbers in your on the frequency side add up to 30, since you should have 30 pieces of data. I'm going to double check, make sure these add up to 30. 6, 4 plus 2, 6, 13, 23, 28, 29, 30. Perfect. Okay, so I made my frequency table. And every time you draw a histogram in your homework or on the review or on the test, you're going to have a frequency table with it. Set up your axes is step 4. The horizontal axis has appropriate numerical variables, class boundaries, and your vertical axis displays frequency. So let me do my vertical axis first. This needs to display frequency. My highest frequency is 10, so I got to go to 10. I'm just going to go by ones, but I'm just going to label every other increment. Okay. And now for my classes, you got to keep them the same width. Okay, so whatever width you choose, just make sure you can make it, you can include all your classes, you have enough room across your grid. I'm just going to go by a width of 2. So I'm going to start right here. I'm going to go with 600 to 650, 700, 750, 800, 850, 900, 950. Okay. So that's my classes, and then I'm going to draw the bars corresponding to their frequency. So the first one has a frequency of 4. So I'm going to draw that up to 4. Then 2. 7. 750 to 800 is the big one, all the way up to 10. 800 to 850 is 5. I'm going to shade them in just so you can see them a little bit easier. You don't have to do this, obviously. I'm going to shade in with pen, not pencil. Just give you some time to finish up. Now there's one thing that we're missing on this graph that every graph we do in this class should always have, and that's a title. So important things to include in your title, anything about an athlete or a team. There's nothing here about an athlete or a team. There is the year though, 2008, that's important. So maybe we'll put run totals for 2008 baseball teams. Okay, and the last thing you should have, I forgot to put here is, I labeled these with the numerical labels, but I forgot to put the verbal label. What do these numbers mean? I know it says run totals, so you have it here, but it wouldn't be a bad idea to just put runs down here too, or you could have written run totals, either one. So that's a histogram to represent this data set. Now let's go to the other side where we're talking about relative frequency histograms. A relative frequency histogram shows the percent or proportion of observations in each class. Okay, so the steps for creating a relative frequency histogram are the same as creating a histogram that we did on the front page, except the frequency table will have a third column. So luckily on the front we started at 600 and went by 50s. This is the same data from the front. Run totals for 30 baseball teams in 2008. This was exactly what our table looked like on the front because these were the classes. We used the same width for our classes and the same starting point, 600. Now, we added a third column right here, which is relative frequency. Relative frequency takes the frequency and divides it by the total. So since there's 30 baseball teams here, in order to get the relative frequency, it's going to be your frequency, which is 4 for this class, and divided by your total, which is 30, and you get about 0.13 with a bar. Then my next one is going to be 2 divided by 30, which gives me 0.06, and that repeats. Next one, now you don't need to show your work for the relative frequency, I'll just show it for the first few. And you can go ahead and finish filling out the chart by dividing the frequencies by the total. Now, your histogram is drawn the same way, except for on the vertical axis, instead of having frequency, we're now doing a relative frequency histogram. So you're going to have relative frequency along the vertical axis. And our highest relative frequency here is 0.33. So, let me just draw this in right here so you can see it. So I just need to know, I need to go up to 0.33. So I'm just going to go by 0.05s. Again, just labeling every other increment. My horizontal axis is still going to be labeled the same. I'm using the same classes. And it's still displaying runs along my horizontal axis. So my first one has to go up to 0.13. Draw your bars in. You do not have to shade it in. I'm just shading it in so you can see it a little easier from your end. Now there's one more thing our graph needs. Again, it's a title. Since we're displaying the same information as we did on the front, can we use the same title that we used for our frequency histogram on the front page? Absolutely. So we said run totals for 2008 baseball teams. Okay, that's it for creating histograms, frequency histograms, and relative frequency histograms, and the review on categorical versus numerical data. Your homework is a worksheet tonight. Make sure each time you're asked to draw a histogram, either one of them, that you include the frequency table along with it. Okay, good luck, guys.